Welcome to this video on domain and range. By the end of this video, you should be able to write the domain and range of a continuous graph in inequality notation. All right, so we talked about domain and range of discrete graphs where we were able to exactly identify the x values and the y values. But in a continuous graph, it's a range of x values and a range of y values. So we'll be writing our inequalities using inequality notation because there's going to be a range of x values and a range of y's. Now, quick review, remember your domain is an x value. So when we're writing our domain, remember we always want to have the smallest number to the biggest number. So you're going to read your graph from the left to the right. Okay. Now for the range, your range are your y values. If I want to put these in order, smallest y value to largest y value, that means I'm going to have to start reading at the bottom of the graph. So we're going to read from the bottom to the top of the graph. All right, so let's try a few of these and see how we do. So we're going to look at number 2 to begin with, because it's going to be a little bit easier to see. Some are very easy to see and some are a little harder to see. So looking at number 2, for domain, you want to look at the left and the right hand side of the graph because domain is an x value and it goes left to right. So when I'm looking at this graph, I can see that the graph does not pass this line, which has an x value of -1, 2, 3. So it's not going to have an x value beyond -3. And when I'm traveling across, the graph ends right here. It's not going past this x value, which is +3. Okay, so we know all of our x values are between -3 and +3. We are talking about x values, so I'm going to put the x value in the middle. Okay, on this side, all of my x values are more than -3. But because the x is here, I'm going to put the bigger side of my inequality towards the x. So that says x's are greater than -3, but they could be equal to because we're dealing with a solid line here. And let's look on the other side. Compared to this 3, all of the x's are less than that number. So x's are less than or equal to -3. So really what we've done is we've kind of written two inequalities together as one. The x values on this side are more than -3, but over here they're less than -3. Okay, so we took these two and we put them together by putting the x in the middle. If I read to the left, I say x is greater than -3, but x is also less than +3. Okay, now let's look at our range. Our range is a y value. You want to write its smallest y value to largest y value. So we start at the bottom. And the first time there's any y values on this graph, the very lowest y value occurs right here. And that y value is -3. And then I have a very top of my graph. It doesn't go on forever and ever. I just have a top of my graph that does not go past +3. So now these numbers just happen to match this time. It's not always like that. So my range, remember we want the smallest number to the biggest number. So it's -3 to +3. We are talking about y values this time, so you do want to put a y in the center of it. Now here's my -3. The y values are above that, meaning they're greater than -3. So I'm going to put the big sides towards the y. It is equal to because it's a solid line. But they are also less than +3. So I'll say less than or equal to +3. All right, well, let's try it again. We'll try one that's a little bit harder. We'll go back over here to number 1. Let's start with our range to begin with. Our range, remember, is a y value. So I'm looking, is there a very bottom of this graph? I do see that the graph does not pass right here. Okay, that y value at that point is -2. But as I'm going up, I'm noticing there's no ending of the graph. This arrow is pointing up because it's going up forever and ever. This arrow is pointing up. because it's going up forever and ever. The graph isn't ending going up. So for my y values, they're going up towards positive infinity. So they're never going to stop going up. We only have one number. Unlike over here, we had two numbers. So my one number for my range is -2. How does the graph compare to the -2? Is the graph above the -2 or below the -2? The graph is above the -2, meaning it's greater than -2. So all of the y values are greater than -2, but because it's a solid line, we're also going to put an equal to. All right, let's try our domain. For our domain, we want to look at the left and the right of the graph. On the left, there is no stopping of this graph. It's going forever and ever and ever. If you went forever left, you would end up where the x values go to -infinity. On the right side of the graph, now this green infinity, that's referring to our range. So that was our bottom up. Now we're using pink for our left and right. Going right, there's a arrow. It's going to continue right forever. So x is to the right forever, or positive infinity. Anytime you go from -infinity to positive infinity, that means there's not a single x value that I cannot pick that is not on the graph. Every single x value ever on this coordinate plane has a corresponding y value to put it onto this graph. So what that is called is all real numbers. Now, all real numbers has a special symbol that we can use. You're going to draw two lines and then turn it into an R. That symbol represents all real numbers. So anytime you have a -infinity to a positive infinity, that means every value is included. We're going to use all real numbers. All right, let's try this again. It just takes some iterations to get used to it. Okay, so let's look at number 4. And we're going to go with domain first. Domain is left and right, so I'm going to look at the left side of the graph. I'm noticing there's an arrow on the left-hand side. That means it's never stopping for my x values on the left, so it's going to go from -infinity on the left. But the right side also has no ending. There's arrows. It's going to continue on and on and on. So the x values on the right go into positive infinity. So that's what we were just saying. If you have a situation with -infinity to positive infinity, that means every single value is included on this graph of x's. So we're going to say that our domain is all real numbers. Now for our range, when we look at our range, I'm noticing that the arrows are pointing down, meaning it's going down forever. The down forever, if we keep going down and down and down, that's -infinity for our y values. Okay, but as I'm going up, I notice the graph turned around right here. It didn't go past this point. And that y value there is 1, 2, 3, 4, 5. So it's never stopping going down, but it did turn around and went no higher than where y is 5. That is only one number. It's a 5. Now, how does the graph compare to 5? Is the graph less than 5 or greater than 5? Is it below 5 or above 5? This graph is below the 5, which means the y values are less than 5, but it's also equal to because we have a solid line. Okay. Now, let's try number 3. Let's start with our domain. Look at the left-hand side of the graph. Here's the left hand of the line. It's got an arrow, so there's not an exact stop spot. It means it's going from -infinity. It's just continuing forever and ever to the left. So I'm going to follow my graph. On the right-hand side, it also has an arrow. So my x values to the right forever go to positive infinity. -infinity to positive infinity is all real numbers. Let's look at our range. The range is the bottom of the graph to the top of the graph. So this side is actually the lower side, but it's got an arrow. There's not a point, there's not a turnaround, there's nothing, meaning it's also going down forever and ever and ever. The y values down forever and ever are negative infinity. On this side over here, we also have an arrow, which means it's going to an infinity, but what infinity is it going to? Well, the y values, it's going up for y values, and y values going up go to positive infinity. So we have another situation where we have negative infinity and positive infinity. So in this case, our range is also all real numbers. Okay, let's try number 5. So number 5, it's a little bit easier. There's no arrows. When you look at the graph, you'll see there's no arrows there. This is a lot easier to see. So let's take a look at our domain. That's the left and right hand side of the graph. There's no arrows, so I know there's no infinities involved. The furthest left that the graph goes is to right here, and that's at -1. The furthest right the graph goes, it never goes past this x value right here, which is 1, 2, 3, 4, 5. So I have two numbers. I know all of my x values are between -1 and 5, and I'm talking about x's. The x's are greater, meaning to the right of -1, so I'm going to put the greater side towards the x, but it's also equal to, because we have solid lines. But the x's are also to the left of the 5, making them less than or equal to 5. Okay, so that's our domain. That's the left and right. Let's do our range, which is the bottom to the top. There is an exact bottom. It doesn't go past this y value right here. That y value is -1, 2, 3. Okay, and on the top, our graph turned around, giving us an exact top point at 1, 2, 3. So all of our y values are between -3 and +3. We are talking about y's, so make sure you put a y in there. The y's are above -3, so we say compared to the y is greater than -3. It can be equal to, because this is a solid line, but they are also less than +3. Okay. All right, let's try number 6. Just seeing lots of examples is most helpful. So on number 6, let's go with domain first. Look at the left-hand side of the graph. The left-hand side of the graph is going left forever. It's never stopping going left. Well, left forever is -infinity for x values. On the right-hand side of the graph, there's an arrow, meaning it's going right forever, which means it's going to +infinity for our x's. So we have a -infinity, +infinity situation, meaning it's never stopping left or right, which is in all real numbers. Okay, now our range. Look at the bottom. It's going down forever because there's an arrow, so down forever is -infinity. And the top of our graph is going up forever because there's an arrow, so that's a +infinity. So for our range, it's -infinity to +infinity, which is all real numbers. All right, let's flip this over and try a couple more. All right, I want to look at number 11. So number 11, let's go with the domain first, which means we're looking at the left and the right. What I notice before I start is I'm noticing I have a closed circle and I have an open circle. So remember, a closed circle is included, so that's an equal to with our inequality. But an open circle is not included, so that would be just a regular inequality. So we're going to have to remember that when we go to write our domain. So we do have a point. There's no arrow on the left. So we are not going past that point on the left, which is where x is -2. On the right, we have a point. There's not an arrow. It doesn't go past this x value, which is 1, 2, 3, 4, 5. So all of our x's are between -2 and 5. Okay, so -2 to 5, and we're talking about the x's. So compared to -2, The x values are to the right of it, making the x values greater than -2, and it's a closed circle, so it's going to be greater than or equal to. So reading it this way, x's are greater than or equal to -2. But on the right, it's an open circle. The graph is less than 5, but it's not going to be equal to it. So we're just going to say less than on that side. Okay, so that's our domain. Those open and closed circles are important. Let's look at our range. Our very lowest point on the graph occurs right there. It doesn't go below there. That is at -2. Now that's an open circle, so we got to remember that. The very highest our graph goes is it doesn't go any higher than that spot right there, which is where y is 1. So all of our y values are between -2 and 1. Okay, so compared to -2, the graph is above -2, so it's greater than. The y's are going to be greater than, but they're not going to be equal to -2 because of that open circle. On the top side, they get up to 1 and turn around. They don't go past 1, but it's a solid line right there. It's not an open circle. So the graph is under that 1, so it's less than or equal to. All right, let's try one more, and let's go with number 13. It's a similar situation, it's a little bit different. Okay, so let's go with domain first. That's your left and your right. On the left-hand side of the graph, there's an arrow, meaning it's going left forever, so that means it's going to -infinity. On the right-hand side of the graph, there's an open circle, and the graph does not go past that x value right there, which is a +2. Now, looking at this, only one of these is a number. I don't have two numbers, so there's not a definite start and stop. I only have the one number, so I'm going to use my 2. And the graph is to the left of it. All of the x values on here are less than 2. But they're not going to be equal to 2 because that's an open circle. So all of the x values are less than 2. Now let's look at our range. Our range goes from the bottom to the top. So let's look at the bottom of the graph. There's an arrow. That means it's going down forever. Down forever for y's is -infinity. I follow the graph up. Well, there is not an arrow on this end. In fact, the graph never passes this line right here, where my y value there is 0. Okay, so we only have one number. Our one number is 0. The other side is a -infinity. We're not going to worry about that. Now, the entire graph that I'm looking at is below 0, so all of my y values are less than 0, but they're not equal to it because of that open circle. So that's going to be our domain and range. Hopefully that was helpful for you. Let me know if you have any questions, and I'll see you in class.